Hello, this is Carl from LunchboxSessions.com. In this video, we'll look at how to read those sometimes confusing looking symbols produced by the manufacturer of load sensing piston pumps. Load sensing pumps, sometimes referred to as a flow compensating pump. This particular symbol is typical of what you find with the Rexroth A10 VSO series pumps with the DFR compensator. To allow the load sensing system to remain balanced and functioning correctly, you need to have some type of throttling mechanism for the flow on the pump's outlet line. Some type of a mechanism that even when that valve is wide open, still produces some restriction against the pump's outlet flow. So in this case, we're showing a very simple needle valve in the small gray box, and we'll be adjusting that needle valve in a moment. On many hydraulic systems where there might be 1, 2, or more valve sections in a valve bank for operating a variety of applications, the valve symbol will look quite a bit more complex. But to study load sense systems, the simple adjustable orifice symbol works out quite well. And in fact, you can find this symbol and such a simple valve on load sense systems where the pump is doing nothing more than powering a single hydraulic motor, typically in use to operate an electric generator. And so, a single speed adjustment control is all that's needed. After the throttling valve, and before the system carries on to that hydraulic motor I was speaking about off the top of the screen, to the right we see a pilot line. That's our load sense signal line carrying back to the pump controller the pressure that is present on the business end of this hydraulic system. What we see inside the pump controller is two symbols. We see the upper symbol moving back and forth, appears to be a 3-port 2-position valve, but also with infinite positioning bars drawn above and below the symbol. That's our flow compensator, or some manufacturers of pumps will call this the load sense compensator. And then the lower one, which is a similar symbol, typically referred to as the pressure compensator or the pressure cutoff. Both of them feature a spring with a diagonal arrow through the spring symbol, indicating that these are adjustable functions on the pump. Let's drop down into the main body of the pump and notice that there are two control pistons. There is a larger diameter main control piston, and when that one pressures up from the right-hand side, that will be pushing our swash plate towards a 0-degree angle and minimizing the displacement of the pump. And then down here at the bottom of the pump symbol, we see a bias piston, and the bias piston is a smaller internal diameter, and it also has a bias spring inside it. And so this piston's job is to try, always, to move the pump towards maximum flow rate, or Qmax. So, which one wins? Well, if all pressures are equal for both the top and bottom piston, due to the superior surface area on the back of the piston for the main control, this upper control piston would move the pump towards Q minimum, or take the pump off stroke, as it's sometimes said. This load sense compensator here at the top of the pump symbol is currently adjusted to 150 psi. How did I work out that? Well, if you're looking at the two gauges, the one below the flow orifice and the one above, what you will notice is that the difference between those two pressure gauges, the delta P, is always about 150 psi. And that was established by adjusting the spring on the load sense compensator, or sometimes called the flow compensator. So I'm just hovering over the adjustment on my controls panel, and you will see the spring up on the flow compensator, lighting up in green to let you know what we are adjusting. All right, you might choose to go back and view a video of ours by the title, What is a Load Sensing Pump? And perhaps also our video, Load Sensing Accuracy, where you will see the cutaway of the two compensators and their two springs, just to remind yourself of what components these symbols represent. And in the next part, we'll get into more of the function of these symbols.